We can now drop the signs on one condition. We use general solution. So there's two possible solutions. The one is 2x is equal to 90 degrees minus x minus 30 degrees, and this is in quadrant 1 plus k times 360, where k is an element of integers. This will now read 2x is equal to 90 minus times a minus is plus 30, which is 120 degrees, minus x, but that minus x can be taken over to make that positive 3x, 2x plus x. 3x is equal to 120 degrees plus k times 360 degrees, where k is an element of integers. That means that x is equal, to get x on its own we divide by 3. What we do to one side we do to the other side. That will be 40 degrees plus k times 360 divided by 3 is 120 degrees. This is only one solution. This is our quadrant 1 solution. Where else does sign operate as positive? In quadrant 2. That means that 2x is equal to 180 degrees minus 90 degrees minus x minus 30. This will mean that 2x is equal to 180 minus 90. Minus times a minus is going to give us positive 30 degrees. 180 minus, so that's minus times the positive 30 degrees, is going to give us negative 30 degrees. So essentially it's 180 degrees minus 90 degrees minus 30 degrees. 180 minus 90 is going to give me 90. 90 minus 30 is going to give me 60 degrees. Minus x times a minus is going to give me positive x plus k times 360, again where k is an element of integers. Take the x across, that will be 2x minus x, which is just x, is equal to 60 degrees plus k times 360 degrees, where k is an element of integers. Here are our two possible solutions. Now, remember I said we need to find our points of intersection. Keep these two solutions written down. I'm going to bring back on my graphs. On this, let us put our two solutions. Our one solution was x is equal to 40 degrees plus k times 120 degrees, where k is an element of integers. Our other solution was x is equal to 60 degrees plus k times 360, again where k is an element of integers. Now let's try and find our points of intersection. When k in this first solution, I just want to erase this piece over here. In our first solution, when k is equal to 0, that's going to be x is equal to 40 degrees plus 0 times 120, which is just 40 degrees. That means that that solution is 40 degrees. When k is equal to 0 here, this solution is going to be 60 degrees plus 0, which is 60 degrees. When k is equal to 1, this is going to be 1 times 120 degrees, which is 120, plus 40, which is 160. When k here is equal to 1, that's going to be 360 degrees plus 60 degrees, which is beyond 360 degrees, so we are not looking for that solution. When k here is equal to 2, that's going to be 40 degrees plus 2 times 120, or plus 240. 240 plus 40 is 280 degrees. That's in the positive axis. Now let's look at the negative axis. The next k value we're going to use is negative 1. When k is equal to negative 1 over here, 40 minus 1, okay, I've got that already, negative 80 degrees. When k is equal to negative 1 over here, that's going to be 60 degrees minus 360 degrees, which is going to be negative 300 degrees. When k is equal to negative 2, that's going to be negative 240 degrees. 40 degrees minus 240 degrees is going to give me negative 200 degrees. And those are all of my points of intersection. Please note that I'm missing another point over there. When k is equal to negative 2, that's negative 200 degrees. When k is equal to negative 2 over here, that's going to go beyond negative 360, so we're not worried about that one. But look here, when k is equal to negative 3, that's going to be negative 360 degrees. 40 degrees minus 360 degrees is going to give me the point negative 320 degrees. Now please note that these 8 points of intersection are only the x values. I have only given you the x values, or the angles. If you want to, and in some cases you are required to, find the total coordinates of each of the points of intersection, I'm going to give you an example on the 40 degrees. The x value is 40 degrees. To get the y value, we're going to have to say sine of 2 times 40 degrees, which is the same as sine of 80 degrees. On a calculator, sine of 80 is going to yield an answer of 0.98. 0.98 rounded off to 2 decimal places. You can do that for all of the angles. I did not bother to do that myself. And that's if they ask you to calculate the coordinates of the points of intersection. I only asked you to calculate the x values, or the angles where the graphs intersect. We are now going to look at interpreting this information. I'm going to take this off because we no longer need it. The first thing I asked you for was, when is f of x greater than or equal to g of x, or rather, for which values of x is f of x greater than or equal to g of x. Now think about that. F of x is the graph sine 2x. G of x is the graph cos of x minus 30 degrees. Basically, I'm asking for which angles, or rather for which x values, is the red graph higher than the blue graph. It's going to be higher than the blue graph over there, even though it doesn't look like it. So that's from negative 320 degrees all the way up until negative 300 degrees.